at Cagayan State University and my master's degree, Master of Science and Teaching, major in Mathematics at St. Paul University, Tuguegarao, Philippines.
Hello, sir.
Yes, sir.
Yeah. So now my stage is yours. So share your screen that audience said seen the screen. Dear participants, we have a quiz competition at the end of the session. So if you want to add some, please join with.
Hello, sir.
Hello, hello. Your screen is visible. To the next slide. Yeah, sir. Continue.
So, can I continue now, sir?
Yeah, definitely.
Hello, sir.
Definitely. Definitely. Continue.
Good day, everyone. I am your next speaker, Joseph D. Talay. I would like to commend everyone for watching on this seminar and would also like to give my warmest welcome to all of you as we play, learn, and grow together with my topic, solving perimeters and areas of plane figures. First thing is we're going to define what is a perimeter. Perimeter says it is the distance around the outside edge of a flat object. It is also reported as a total number of linear units. Now, when you measure the amount of wallpaper border to go around the room, you measure it in lengths. May I ask you, would the perimeter of your bedroom or the perimeter of your house, which among the two is greater? Is it the perimeter of your house is greater than the perimeter of your bedroom simply because your bedroom is just a part of the main house? Okay. We're going to find the perimeter of the surface if each square is equal to 1 foot. So, we're going to count the number of sides. So, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So, the perimeter of the figure is 24 feet. So next, we're going to define what is an area. As a definition, area is the amount of the surface space that a flat object has, and it is reported in the amount of square units. Again, when you measure the amount of carpet to cover the floor of a room, you measure it in square units. May I ask you, is the area of your bedroom greater than the area of your house? It's simply the area of your house is greater than the area of your bedroom. Again, because your bedroom is just a part of the main house. Now, we're going to remember these formulas. First, what is the formula in computing for the area of a square? Simply, it is side times side. So we have side squared units. Next, what is the formula for computing the area of a triangle? Area of a triangle is just simply equal to 1/2 times base times height square units. And area of a rectangle is length times width times square units. So we're going to remember these three formulas. Area of a square, side times side. Area of triangle, 1/2 times base times height. And area of a rectangle is length times width times width. Next, we're going to find the area of the surface if each square is equal to 1 foot. We're going to count the number of squares. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So the area of the figure is 15 square feet. Now, let's have another example. Two neighbors build swimming pools. This is what the pools look like for family A and for family B. May I ask you, which family has a pool with a bigger swimming area? Is it family A or family B? It is the area of family A. Family A's pool is 8 square units. So as you can see, there are 8 squares. And for family B, the area of family B pool is 7 square units. Therefore, the family A has a pool with a bigger swimming area. Next, same question. Now, again, we're going to look at the same two pools. Which family has more side panels of the pool to clean? For family A, for family A, the perimeter of family A pool is 12 units. How about for family B? Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So the perimeter of family B's pool is 14 units long. Therefore, family B has more side panels of the pool to clean. Okay, we're going to tackle more example on the application of the area and perimeter of a plane figures. First, what do you think, or we're going to find the area of the shaded region if A and B are squares of sides 5 centimeters and 8 centimeters respectively. I will give you 10 seconds to answer. Okay. As the problem says, the measure of two squares is 5 centimeters and 8 centimeters. Now, what do you think is the measure of this side? It's actually 3 centimeters. As you look on the figure, how many unshaded triangle can be formed? So we have triangle A, triangle B, and triangle C. So, how are we going to compute for the area of the shaded region? Simply, the first thing we're going to do is to find for the area of triangle A, triangle B, and triangle C. So, again, what is the formula in computing for the area of a triangle? So we have area is just simply equal to 1/2 times base times height. So, for the area of triangle A, we have 1/2 times 5 being the base and 5 being the height. So if you're going to solve that one, that is 1/2 times 5 times 5. The area of triangle A is 12.5 square centimeters. Next, for the area of triangle B, what is the base and what is the height? So, for the area of triangle B, we have 1/2 times base times height. That is, your base is 8 and your height is 3. So we have to solve that one, we have 1/2 times 8 times 3 is just simply equal to 12 square centimeters. Next, the last triangle, the area of triangle C. What is the base of the triangle? As we can see, the base is just simply the sum of 5 and 8, and its height is 8. Therefore, the area of triangle C is simply equal to 1/2 times the sum of 5 plus 8, which is 13, times 8, and the answer is 52 square centimeters. So that is the area of the three triangle, the unshaded triangle, the area of A, B, and C. So next, after that, we are done in computing for the area of triangle A, B, and C. Now, we're going to compute for the area of the two squares. The total area of two squares is just simply, again, as a review, the area of a square is just simply equal to side times side. So we have 5 times 5 being the measure of the side of the small square, and 8 times 8 being the side of the bigger square. So if you're going to solve that one, that is simply equal to 25 plus 64 is equal to 89 square centimeters. Therefore, we are now ready to compute for the area of the shaded region. Just simply, we're going to subtract the area of the three triangles, triangle A, B, C, from the area of the two squares, which is 89 square centimeter. So that is, we have 89 minus 12.5 being the area of triangle A, minus 12 the area of triangle B, minus 52 the area of triangle C is equal to 12.5 square centimeters. Therefore, the area of the shaded region is 12.5 square centimeters. Did we arrive at the same answer? Our next example. Example number 2. What is the sum of the areas of two squares? We have the A, square A and B is 202 square centimeters. Again, the sum of the areas of the two squares A and B is 202 square centimeters. What is the area of the figure? So I'll give you 10 seconds. Okay, what do you think is about the perimeter of the figure? That's how we're going to study the solution. The first thing we're going to do is to make a list of the areas of different size. So, that is 2 times 2 is equal to 4. 3 times 3 is equal to 9. 4 times 4 is equal to 16. 5 times 5 is equal to 25. 6 times 6 is equal to 36. 7 times 7 is equal to 49. 8 times 8 is equal to 64. 9 times 9 is equal to 81. 10 times 10 is equal to 100. And 11 times 11 is equal to 121. Now, based on that, we're going to look for two numbers that will add up to 202. Take note that the sum of the two squares A and B 2. What do you think? Based from that, what two number that if you're going to add will give you 202? It is 81 and 121. So 81 plus 181 is equal to 202. Therefore, the sides of the two squares is 9 and 11 respectively. So the sides of the two squares are 11 centimeters and 9 centimeters respectively. So we have 11. Next, we are now ready to compute for the perimeter of the given figure. So 11, so there are 3, 11 times 3 plus 9. So we have 9 times 3 plus the measure of this side. What do you think is the measure of this side? So this is just simply equal to 11 minus 9. So we are now ready to compute for the perimeter of the given two squares. That is 11 times 3 plus 9 times 3 plus 11 minus 9 will give us 62 centimeters. Therefore, we could now conclude, or we could now say that the perimeter of the figure is 62 centimeters. Did we arrive with the same answer? Okay. We have example number 3. The figure below is formed by two squares of sides 6 centimeters and 4 centimeters respectively, as shown in the figure. Now, we're going to find the area of the shaded region. This problem, example number 3, is something same with example number 1. So, what do you think is the area of the shaded region? I will give you 10 seconds to think for a solution for that. So, let's see if we have the same answer. So this is the figure. The measure of the one square is 4 centimeters. The other is 6 centimeters. And we're going to find 6 centimeters. Next, as we can see, we could form how many triangles? How many unshaded triangles that we could form? We have first triangle, we have triangle ABC, and the second triangle, triangle CEF. So, again, we're going to find for the area of the two triangles. We have the area of triangle ABC. Again, the area of a triangle is computed as 1/2 times base times height. From triangle ABC, what is your height and what is your base? The height and the base is just simply equal to 6. Therefore, the area of triangle ABC is equal to 1/2 times 6 times 6 will give us 18 square centimeters. So that is the area of triangle ABC. Next, we're going to compute for the area of triangle CEF. First, what is the base of triangle CEF? Very good. It is the sum of 6 and 4, and its height is just simply equal to 4. Therefore, the area of triangle CEF is computed as 1/2 times 10 times 4 will give us an answer of 20 centimeters. So the area of triangle ABC is 18 centimeters, and the area of triangle CEF is 20 square centimeters. Now, are we ready to compute for the area of the shaded region? Not yet, because we're going to find first the area of the two squares. So, the area of the two squares is just simply the sum of the area of the first square, which is 6 times 6, and the area of the second square, which is 4 times 4, will give us 36 plus 16 is equal to 52 square centimeters. So this is the area of the two squares. What are we going to do with this? We're now going to subtract the area of the two triangle ABC and the triangle CEF from the area of the two squares. So we have 52 minus 18 as the area of triangle ABC minus 20 as the area of triangle CEF will give us 14 square centimeters. Therefore, we could now say that the area of the shaded region is 14 square centimeters. Did we arrive at the same answer? Next example. Example number 4. The side of each square is 1 centimeters. Find the area of the shaded region. Again, the side of each square is 1 centimeter. Find the area of the shaded region. What do you think is the area of the shaded region? Okay, we're going to discuss the solution. First is we're going to count how many squares that is not being embedded with the two triangles, with the two shaded triangles. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are the number of squares is equal to 9, and its area a while back, we have now the area of the 9 squares is simply equal to 1 times 1 times 9 is equal to 9 square centimeters. Next, we are not yet done, because as we look on the figure, how many triangles can we see? How many unshaded triangles can we see? Let's count. We have triangle A, triangle B, triangle C, triangle D, and triangle E. So we're going to find again the area of each triangle. So what is the area of triangle A? Take note that the measure of the side of each square is 1 centimeters. So what is the base and what is the height of triangle A? The base is just simply equal to 2 and its height is equal to 1. Therefore, the area of A is equal to 1/2 times 2 times 1. If you're going to simplify or going to solve it, you can now derive 1 square centimeter as the area of triangle A. How about the area of triangle B? What is the base and what is the height? So, the area of triangle B, which is equal to 1/2 times 2 as its base times 3 as its height, will give us 3 square centimeters. Next, we're going to find for the area of triangle C. The area of triangle C is equal to 1/2 times 4 times 1 is equal to 2 square centimeters. We're not yet done. We're going to compute again for the area of triangle D and triangle E. So we have for the triangle D simply equal to 1/2 times 1 times 3 will give us 1.5 square centimeters. And next, for the area of triangle E is equal to 1/2 times 1 times 2 is equal to 1 square centimeters. Are we now ready to compute for the area of the shaded region? We're going to find first the area of the whole square. What do you think is the area of the whole square? It's simply given us 5 times 5. So this is the area of the whole square. That is 5 times 5. So we're going now to subtract the area of the 9 squares and the area of the 5 triangles. So that is 9 minus the sum of the area of the 5 triangles. And if we're going to simplify that, will give us the answer of 7.5 square centimeters. Therefore, we could say, or we could now conclude that the area of the shaded region is 7.5 square centimeters. Are there questions? We'll now proceed to example 5. What do you think is the area of the shaded rectangle based on the figure? The problem is ABCD is a square of side 8 centimeters. So we have a square ABCD wherein segment AG is equal to segment AC which measures 5 centimeters. So what is the area of the shaded rectangle EFGH? What are we going to do? Take note that AG and EC is 5 centimeters. So if we're going to add AG and EC, we have now 5 plus 5 is equal to 10. Next, it will give us now, so in order for us to compute for the measure of the side HG, we're going to find for the sum of the measure AG plus EC, which is simply given as 5 plus 5 is equal to 10. So where did we get 8? 8 is actually given a while back that the measure of the square is 8. The measure of the side of the square is 8 centimeters. Therefore, the HG is just simply equal to 10 minus 8. So, we could now get for the area of the rectangle EFHG, that is 10 minus 8, which is, this is the length of the rectangle, times 10 minus 8 is the width of the rectangle, and 8 is the length of it. Therefore, if you're going to solve this one, that is 10 minus 8 will give us 2 times 8 is equal to 16 square centimeters. Therefore, we could now conclude that the area of rectangle EFGH is just simply equal to 16 square centimeters. Are we ready for the next example? For the next example, that is the figure. The figure below is formed by two isosceles triangles. What is, again, the definition, or we could describe an isosceles triangle, or when can we say that triangle is an isosceles? Simply, if the legs are equal. The bases of the triangles are 10 centimeters and 5 centimeters respectively. Now, we're going to find the area of the shaded region. Take note that the triangle is an isosceles triangle. We have two isosceles triangle, the unshaded part and the triangle as a whole. Now, we're going to find for the area of the shaded region. So, in the shaded region, how many isosceles triangle can be formed? Simply, this triangle A is just equal to the triangle a while back. So, in this, we can now say that the area of triangle A is just simply equal to 1/2 times 5 times 2.5 is equal to 6.25 square centimeters. Then, from the shaded part, we could form 3 triangles. That is why the area of the shaded region is 3 times 6.25 is equal to 18.75 square centimeters. Therefore, its area is 18.75 square centimeters. Okay, next. Let's have another example. This example is same with example number 3. The difference in the areas of the square A and the square B is 5 square centimeters. Find the perimeter of the figure. So first, we're going to make a list of the areas of the different sides. So from that, we're going to look at the numbers of the... We look for the difference between the two square numbers. That is equal to... The difference is 5. So, that is, we have 144 and 49. we could now say that the area of or the sides of the two square is equal to 12 and 7. The size of two squares is equal to 5 and 7. Yeah. Next is the measure of this size. That is 12 minus 7. So we are now ready to compute for the perimeter of the two squares. So simply, given us 12 times 3 plus 7 times 3 plus 12 minus 7 will give us 52 centimeters. So the perimeter is 52 centimeters. The perimeter of the figure is 52 centimeters. Next, example 8. What do you think is the area of the big square shown below? The area of the big square shown below is 28.44 square meters. We're going to find the total area of the regions A and B. From the figure, how many squares, small squares, can we see? There are actually 9 squares, right? Now, let's focus on the two triangles, the shaded triangles. How many squares can be formed from triangle A and triangle B? Is it 4? So, from the figure, the total number of shaded squares is 4. We have 2 from A and 2 from B. Therefore, that is just simply equal to the 4/9 of the area of the whole square. So we could now conclude that the area of A and B is just simply equal to the 4/9 of 28.44 will give us an answer of 12.64 square centimeters. Therefore, the total area of the regions A and B is equal to 12.64 square centimeters. Did we arrive at the same answer? Next example. Two parallelograms overlap like the one shown in the figure on the right. Find the area of the shaded region. Take note that the area of parallelogram is given as base times height. So, the area of a parallelogram is given as 3 times 8. So as we can see, its base is equal to 3 and its height is equal to 8 will give us the area of parallelogram is 24 square centimeters. But we're going to find for the area of the shaded region. Next from that, we're going to find first the area of the triangle below that we can see. That is, the area of this small triangle is simply given as 1/2 times 3 as the base, and its height is 8 minus 5, which is 3. So we have 1/2 times 3 will give us 4.5 square centimeters. Now, we could now solve the area of the shaded region, which is just simply equal to 24 minus 4.5 will give us 19.5 square centimeters. Therefore, the area of the shaded region is 19.5 square centimeters. Next example. Example 10. The side of each grid is 2 centimeters. find the area of the shaded region. What do you think is the area of the shaded region? As we all know, the side of each grid is 2 centimeters. From the figure, we could now say that these are the sides of the triangle that we could form. We have actually triangles. We have actually 4 triangles. But before that, what is the area of the square grid? Take note. That is 10 times 6. 10 being its length and 6 being its width. That is 6 plus 4 is equal to 10 and 4 plus 2 is equal to 6. Therefore, the area of the square grid is equal to 60 square centimeters. So, next, we're going to find for the area of triangle A, triangle B, triangle C, and triangle D, which is simply given us for triangle A. That is the area of triangle A is 1/2 times 6 times 4 is equal to 12 square centimeters. For triangle B, 1/2 times 4 times 4 is equal to 8 square centimeters. For triangle C, we have 1/2 times 6 times 2 is equal to 6 square centimeters. And for triangle D is equal to 1/2 times 4 times 2 is equal to 4 square centimeters. We're going to add all the area of the triangle A, B, C, and D and subtract it from the area of the whole rectangle. So simply, this is the equation. That is 60 minus 12 minus 8 minus 6 minus 4 will give us 30 square centimeters. So we could now say that the area of the shaded region is 30 square centimeters. Next, we have now example number 11. For example number 11, we're going to find for the area of the rectangle that is embedded in the square. So that is the area of the rectangle that is embedded in that square. So as we can see, we could actually see 4 triangles. We have 2 small triangles and 2 big triangles. So, we're going to compute for the area of the square first. That is given as 10 times 10 is equal to 100 square centimeters. The next, the area of 2 small triangles. As we can see, from the upper top, the measure of the side of the triangle is given as 3 by 3. Since we have 2 small triangles, that is 2 times 1/2 times 3 times 3 will give us 9 square centimeters. The next, the area of the bigger triangle. That is, which measures 7 by 7. So we have the area of 2 big triangle. We have 2 times 1/2 times 7 times 7 is equal to 49 square centimeters. Then we could now compute for the area of the rectangle. That is 100 minus 9 being the area of the 2 small triangles minus 49 being the area of the 2 big triangles. So will give us 42 square centimeters. Therefore, the area of a rectangle that is embedded in the square is 42 square centimeters. Okay, we have still example 12. For example 12, Triangle ABCD is a rectangle formed by 5 identical small rectangles. The width of each small rectangle is 6 centimeters. Find the perimeter of the rectangle A, B, C, and P. So we have the width of each small rectangle is 6 centimeters. What do you think is the length of each rectangle? That is unknown. We cannot easily know if what is the length of the rectangle. Okay, we're going to study it. So as we can see, the width is equal to 6, right? This is equal to 6. And what do you think is the length? AB is equal to 3 times 6 is equal to 18 centimeters. Therefore, the length of AB is equal to 18 centimeters. That is the length of each small rectangle. We're going to divide it by 2. That is 18 divided by 2 is equal to 9. Therefore, the length of each rectangle is equal to 9. Now, are we now ready to compute for the perimeter of the square A, B, and C? So we have how many 6 we could see? That is 6 plus 6 plus 6 plus 9 plus 6 plus 9 plus 9 plus 6 plus 9 is equal to 66 centimeters. So, 6 plus 6 plus 6 is the length of AB. 9 plus 6 is the length of BC. 9 plus 9 is the length of CD. 6 plus 9 is the length of AD. That is why the perimeter of the square ABCD is equal to 66 centimeters. Did we arrive at the same answer? Next, example number 13. Triangle ABC is a parallelogram wherein EFG is equal to 6 square centimeter. EFG is equal to the area of triangle EFG is equal to 6 square centimeters. DE is equal to EF is just simply equal to the 1/3 of CD. We're going to find the area of the parallelogram ABCD. Take note. Triangle EFG has an area of 6 square centimeters. Now, what do you think is the similarities of triangle DEG, triangle EFG, and triangle FCG? What do you think? They are just the same. Since the area of EFG is equal to 6, we're going to multiply it by 3. So 6 times 3 is equal to 18 square centimeter. Therefore, we could say that the area of DGC is equal to 18 square centimeters. And from that, we could now say that there are 4 triangles. That is triangle AGD, triangle GDC, triangle CGB, and triangle AGB are equal. That is why we have 4 times 18 is equal to 72 square centimeters. We could now deduce that the area of parallelogram ABCD is just simply equal to 72 square centimeters. Okay, this is the second to the last example. Example number 14. Line AE is equal to line EF, which is 1/3 of line AB. This is just the same of the previous example. Area of ADE is 5 square centimeters. If D is the midpoint of line BC, find the area of ABC. Take note that triangle ADB and triangle ADC are equal. Triangle may I repeat, triangle ADB and triangle ADC are equal. Also, triangle ADE, triangle EDF, triangle FDB are also equal. Since the measure of the area of triangle AEF, area of ADE is equal to the area of EDF is equal to the area of FBD, as they have the same base and height. So we could now say the area of ABD, the whole ABD, is just simply equal to 3 times 5. 5 is actually the area of ADE, which is given on the problem. So we have 3 times 5 is equal to 15 square centimeters. We could now say that the area of triangle ABD is equal to 15 square centimeters. Like what I said a while back, that the area of ABD is equal to the area of ADC, as the base and the height of the two triangles are also the same. So we could now say that the area of ABC is equal to 15 times 2 is equal to 30 square centimeters. Hope we arrive at the same answers. Okay, this would be my last example. Two squares whose areas are x square centimeters and y square centimeters are embedded in a square ABCD. The area of the square ABCD is 252 square centimeters. What do you think is the values of x and y? What do you think is the values of x first? Again, two squares whose areas are x square centimeters and y square centimeters are embedded in a square ABCD. The area of a square ABCD is 252 square centimeters. Find the values of x and y. First, we're going to find for the value of x. What do you think is the value of x? Now, we're going to make alright, let's analyze. We could say that 1/2 of a square ABCD, 1/2 of the square ABCD is equal to 252, being it's the area of the square ABCD divided by 2 is equal to 126 square centimeters. Therefore, triangle ABD has 126 square centimeters as its area. So x is half of 126 square centimeters. That is ABD. So we could now say that x is equal to 126 divided by 2 is equal to 63 square centimeters. So the area of the first square is 63 square centimeters. Next, What do you think is the relationship of the next squares? For y. Y is actually equal to 4/9 of BCD if we can section it into 9 equal parts. Now, triangle BCD, the area of it is 126. And the square of y, that is how many congruent triangles can we form from triangle BCD? There are actually 9 congruent triangles. But inside that square, y square centimeters, we could only form 4 triangles. That is why we could say that y is just the 4/9 of triangle BCD. So in order for us to compute, we could now say that y is equal to the 4/9 of 126, which is simply equal to 56 square centimeters. Therefore, we could now say that the values of x and y are 63 square centimeters and 56 square centimeters respectively. Okay? So next is, okay. So that's end my discussion. Thank you for listening, and I hope that you have learned from my topic, the perimeters and area of the plane figures. I wish everyone a good health and keep safe.